Hi folks, so today what we're going to do is another question on surface geometry and specifically focusing on another development. Just going to read the question first. So it says here, a lamp is shown in the graphic, so we can see the lamp here. We can see the lampshade that the question is going to be based off. It says the lampshade has a square base while the top is circular, or is a circle. The projections of the lampshade are given. Complete a one-piece surface development of the lampshade. Okay, so as we can see here, we've got the lampshade over here and we've got the orthographic of it here with the elevation, and we have the plan view here. Now, they've told us that it is square based on the bottom of it and the top of it is circular. So this is actually a transition piece where it is basically going from a square based bottom up into a circle at the top. And what we have to do is we have to work out the right way to complete that. Okay, so first of all, what we're going to do is I'm actually going to split up my circle on the top of it into 30, 60 degrees into 12 equal parts. So I'll just get that done there now. Okay. Now that that has been split up, what I'm actually going to do is I'm going to use labels as well. Okay, so for the square base on the bottom, I'm going to label it with letters. So I'm going to go A, B, C, and D, and with the top of it here, I'm going to use numbers. So I'm going to start with 1 here, 2, 3, 4, and so on. Okay, having labelled that now, what I'm actually going to do is we're going to use the triangulation method, which we have previously used in other questions to be able to complete the surface development of this. But first of all, there is some flat surfaces on this structure, and it's just about recognising where they are. So, showing you here on the very bottom, if I join A to the bottom of the circle here, which is number 4, and do the same over here, join to B, we can actually see, there we go. We can actually see that that's actually a plane surface there. None of that is actually starting to curve. That's just coming up there nice and straight, perfect triangle. It's not curved in any way at all yet. Okay? And that will actually be the same the whole way around. So from A to 1, 1 to D, into the centers. Okay? So set that up first of all. And there we go. Now, if we have it done in plan, we must also do it in elevation. So, labels first of all. So A and D are on this side. A is at the front, D is at the back, and B is at the front, C is at the back. And same thing with the letters, or sorry, with the numbers. So 1 was all the way up there. I have that already. Just transfer it up anyway. Do the same with 7. And then bring up the others. So 6 and 8 will correspond with each other. And there we go. So, label them as well. So it'll be 1, 2, 3, 4, 5, 6, 7. Then we'd have 8 at the back, 9, 10, 11, 12. Okay. Now, have we joined up our generators, or well, not generators, but the planes in plan? So A to 1, yes, A to 1 is already joined, 1 to D, and so on. And then we've also got D to 10. So I could join D to 10. Just to show you the positioning of that line there in plan. This is it in elevation, and then 10 to C, which would be the same as B to 4 and A to 4. Okay, now using that, we can actually see here one of our surfaces straight away. We've got A, B, 4, and we can see it here, A, B, 4. So what it is we're going to have to basically get the true shapes of all of those. So we can see there's a couple of them here. We've got AB4, that triangle here, okay, that's a plane surface. We've got A1D, this triangle, the exact same plane surface. You can see where I'm going with this, C, D and 10, all another plane surface. And then we've got C, 7, B, another one here, plane surface. The problem is it's these sections inside and here, in these four corners there. And the problem is, at those sections, that's where, if you can imagine, as it's folding up, that's where the curved part of it is starting to bend around the sides. Okay, because that's where it's starting to change from a square into a circle. And what we have to do is we're going to have to basically use simple, it's the exact same method as we've previously done in other questions, it's the triangulation method. So the exact same thing, I'm going to join A to 2 and so on, A to 3, five to B, all the way around. And if I haven't joined in plan, should I also join them in elevation? Yes, I should. So A to 4 is already done, as we can see here, A to 4. So now we've got A to 3, A to 2, A to 1. And as you can see, A to 3 will actually be the same as D to 11. A to 2 will be the same as 12 to D. So it's the exact same. And it's going to work out the same on this side as well. Okay, so if we have it done in plan, always do it in elevation as well. Now the thing is, we have to work out the true lengths of all of these various lines here. Okay, so first of all, if we just work out here, look, A to 1 is the same as 1 to D, which is the same as 10 to D, 10 to C, 7 to C, 7 to B, B or 4 to B, and 4 back to A. Every one of those extreme outside lines are all the exact same true length. It's just recognizing that. So we don't have to figure out the length of all of them. Once we have it done once, we have it for all of them then. Okay? So one way we could actually do that is using the cones method. And the way I'm actually going to use it this time is I'm going to just set it up here. So what I'm going to do is we have to find the true length from the line A to 1, or technically 1 to D, or whatever we want to call it. In this case, I'll call it A to 1. Okay? If we imagine 1 as the apex of a cone, okay, which is the top of a cone. So we know where 1 is up here. That's the height of it right there. So I'll label that 1. Okay, right there in that spot there. And this is going to be very important. Now, when we look down on top of it in plan, if 1 was the apex of a cone and A was a point on the ground of a cone, then my radius is 1 to A. That is the distance of my radius. And at that point, if it was a cone I was drawing here, I would basically, using 1 as the center point and A as my radius point, I would draw a circle. But what I'm going to do is, because I know the radius from 1 to A, I just take that distance on my compass. So I take the distance from 1 to A, that distance there, and I know 1 is here. So if that was the radius in plan, well, my radius in elevation, I would literally have that distance that was on my compass, I would literally just step it out right there. And that there is my A. And now I can join that up to 1. Very simple. And that there is a true length. That there is my true length from 1 to A, which, as I said, is the same as 4 to A, 1 to D, 10 to D, 10 to C, 7 to C, 7 to B, 4 to B. So you could write all those in, but as long as you just recognize, I'll write in about 3 or 4 of them there. So that's 1 to A, which is the same as 4 to A, 1 to D, 10 to D. So there's the A's and the D's done. I might as well put in the rest. 4 to B, 7 to B, and now we just have the C's, 7 to C, and 10 to C. So that's all 8 of them there. You could write them in, you don't have to. Probably makes it a little bit less neat just seeing all these kind of random numbers and letters here, but they all do serve a purpose. Now, So at that point there, straight away, we've actually worked out the true lengths of various lines here. As I said, these ones here, all on the outside. We'll work out the middle ones in a second. Just before I get onto that, what you also have to recognize is, because this is sitting on the ground, and it's a square surface, that means this square here, A to B, B to C, C to D, D back to A, all these outside lines are all true lengths because they're sitting on the ground. And as we look down the top of them, because they're flat on the ground, they are all true lengths. So that's another true length we've worked out. Now, what we also have to work out is the true length from 2 to A, which is the same as the true length from 3 to A, 5 to B, 6 to B, 8 to C, 9 to C, 11 to D, and 12 to D. It's just recognizing you'd have to be good, because you have to understand that inside here we split it up evenly 30-60. So that distance from 2 to A is the same as the distance from 3 to A, and same on over here. Okay? So using the exact same method, 2, we'll take that as the apex of a cone, and from 2 to A as the radius. Now, watch, we have 2 already here, so watch, I'll actually just step it out and we'll use the 2 different true lengths. So I'm going to actually increase this line out here a little bit further. Okay, and imagine it as 2 was the apex of a cone, so I'll extend this out a little bit. And in this case, I'm going to imagine this point up here at the very, very top as 2. That's the apex of my cone. Now I'm going to step the radius right there, that distance there. And in my elevation, the radius would just literally be straight out here. And there we go. That is now my A. And once again, join that up to 2, and that gives me my true length. So there's my true length from 2 to A, which is the same as 3 to A. And then I'll keep doing it, I might as well. So I'll do the B's now. 5 to B, 6 to B, now I'm onto the C's, 8 to C, 9 to C, and then I've got 11 to D and 12 to D, 11 to D, 12 to D. Obviously, once again, you can see the true length is the distance from here to here, and it obviously does look a bit messy when I put in all those, but I'm just doing that, and I'm actually just going to tick them off as I use them. Very important. Okay? Now, what we're going to do is, we have all our true lengths at this stage, so I'm going to pick a start point to start the question. I'm going to pick this point right here, and I'm going to imagine that, because we have the base, that's handy for us to use at the very start. I'm going to imagine that as point A, okay? And I'm going to start off with A to B, which is going to go down here straight, okay? So, A to B is going to go straight down. Not sure exactly how far just yet, but I can take my true length from here, mark it off, and that's my B. The label is very important. Now, what I want to create is this triangle here, A4B, as you can see it, or AB4, whatever way you want to call it. Technically, actually, I could do the other one here. I could do A1D as well. That's one actually I'll do. I'll do the triangle A1D instead of A4D. Makes no difference, but I'm going to start with this one here, and I'm going to tick them off as I do them. Okay? So, have I got the true length from the A to 1? Yes, I do. It's up. It's this true length here, the first one I got. So I'm going to get that distance on my compass. And at A, so an arc. Now, A to, and I should have actually, no, actually, do you know what? Sorry, apologies. Because I have this labeled already, I said I was doing A1D. Because I had it labeled B already, I'm going to do A4B. Now, as I said, A to 1, somewhere along that there is point 4. So it's actually this length I'm getting, A to 4, which is the same as B to 4, which is the same distance right here. So there's my B to 4. So in this case, I have found point 4, right there. And once again, we'll join that up. This out of the way now. So there we go. That is actually the true shape of our triangle A4B or AB4. So I'll just tick him. He's done. Okay. Now, what I want to do is, now I have this little bit after I've got that one, I have this section from 4 to 5 to 6 to 7. Okay? So what we have to do is, first of all, from 4 to 5, is that is the same distance as from 4 to 3. This distance from here to here is the same as from here to here. So that distance there is the same as that distance there. And obviously we cannot measure on a page with a ruler or with a set square the distance. So what we do is we take the closest accurate distance on it, just like that. So that distance there is the same as that there. So from 4, either side of 4, on that side it's going to work out to be the 3, and on this side it's going to work out to be the 5. And somewhere along those two arcs that I've just scribed is going to be 5 and 3, but I have to find the exact points on them. And to find the exact points is, somewhere along there, do I have the true length from B to 5? Yes, I do. It is this guy over here, which is the same as the true length from A to 3. So at that point then, what I can simply do is literally take that distance there, and from A, make a little mark to cut it, the exact same from B. Now, just to show you it's been done, join that up and join this guy up. Now you might think here I just joined that with a straight line there. No, the reason for it is because remember, if I label it, this was our 0.5, this was our 0.3, and you remember 3 to 4 to 5, as you can see, it's not a straight line, it's a curve. So we'll start putting in that curve at a later point once we get a little bit more clear on where we're going with this. So now I'm going to find 5 to 6, just that distance once again there, which is the same as 3 to 2. So I can keep working my way around. So there's somewhere along there is going to be 2, somewhere along here is going to be 6. And once again we need the true lengths from 2 to A and 6 to B, which is this guy here. And there we go. From A, make a mark. From B, make a mark. So that's 6, that'll be 2. And now we have to find 7 and 1. So 6 to 7, that distance there, which is the same as from 2 to 1. So where it is on 2, make a mark or an arc, and the exact same here. Might have to go a little bit further down. And then once again taking the true length. This time now I'm taking the true length from A to 1, which is the same as B to 7, which you have to recognize is this guy. It's not this one, it's this one. It's very important you take the right one, because there is a little bit of a difference. There we go. And there we go. There's our 7 and there's our 1. Now at this point I will start to join it back up, and you'll start to kind of see how it has been folded out. Okay, what I'll actually do very quickly is, now at this point, just to show you, I have done this guy, this guy, this guy, this guy, this guy, and this guy, and I've done the big one. So we have 7 of them done. So watch, space, 1, 2, 3, the big one here, 4, 5, 6, 7. Now I'm going to complete this triangle, which is the A1D. He's going to be completed up here. And then I'm going to do the triangle B7C as well. So I'll just get them done. So I'm going to take the true distance from A to D, or the true length. Somewhere along there is going to be my D. And then I need the true length from, probably have to be somewhere a little bit more there. And I also need the true length from D to 1. And because we have 1 already, so it's D to 1, which is this guy here. Because we have the 1 already, I can find the D by marking it there. There we go. There's my next big triangle. there is our D. And I'll do the exact same down here. Take the true length from, I've done DA, AB, now I'm on to BC. That distance there. And somewhere down along here is going to be my C, somewhere along that arc. And I'm going to take the true length from C to 7, which was this guy over here. And I have the 7, so I'm trying to find C, and that will give me C, right there. Okay, join them up. Now, as you can see, it is starting to take a little bit of shape here. So what I'll do is, you can see where this bit in here is meant to curve. I'm going to start slowly putting in that curve. Okay, now just with the space, and you can see kind of, I'm just going to adjust this a little bit now. You can see it a little bit better there. Now, just with the space that I have left, I'm not going to have much room left inside here, so I'm going to continue it out down along here, so I am. Okay, so at this stage now, I have, if we just tick it off, I've done this guy and I've done this guy. So we have one big triangle left and we've got these bits in here. Okay, so to be able to do that, I need the true distance, or the true length from 7 to 8, which is this point to this point, 7 to 8. So I'll take that on my compass. That distance there. So 7 to 8. And if we think we're at 1, which was here, so I could do 1 to 12, I could fit in a few more up here. So 12 is going to be somewhere out there, and 8 is going to be somewhere out here. Now I need the true length from C to 8, which is the same as 12 to D, which was this true length over here. Just take the right one. So from D, mark it there, and from C, mark it here. And always label as you go so you don't get confused. So that's my 8, and that one there is my 12. Okay, now same thing, I want to find 8 to 9, which is the same as 12 to 11, which is the same as 12 to 11. Somewhere out along here is 9, and from 12 somewhere out there is 11. And same thing, true length from 9 to C is the same as 11 to D, which is this guy here. And there we go. Just fit it there. Now it was comfortable. So there's my 9, and there's my 11. Okay, so I'll take them off actually just so I'm going. So I've done that one, I've done that one, I've done that one, and I've done that one. So you'll actually see here now we've got from 9 to 10 and 11 to 10. So if we're finishing at 10, that will roughly work out to be one of our last ones when we're nearly done there. So take the true length from 10 to 9, which is the same as 11 to 10. That distance right there. So from 9 out here is going to be my 10 somewhere, and from 11 out here is going to be my 10 somewhere as well. And now this time I have to take the true length from C to 10 and D to 10, which happens to be this one. Not this one, it's this one. Take that distance there. From D, do it there, and there, and there is my 10 and 10. And once again, like the last time, join them all up. Okay, and as you can see, I've done that one now and that one, and the last one we have left is just a triangle CD10, and it's just a case of where would that fit better. And as I previously said, I don't think it'll fit in too great up here, so I'm going to do it down here. So it's going to be CD is going to be over here somewhere. So take the true length from C to D, C to D, somewhere out along there is going to be, along that arc is going to be D, and now I need the true length from 10 to D, that true length there, which was this guy. There we go, we had 10 already, so we want to find D, and there it is, there is our D. Once again, join that up, and what you'll notice is where I finished on this side, the 10 to D, is where I finished at 10 to D on that side. And all we have to do then is literally just heavy it in. So I will fast forward there now. Okay, that's the actual question complete there now, guys. That's the complete surface development of the transition piece of the lampshade, where it was a square base at the bottom moving up to a circular top. And what we used was the triangulation method there. Now once again, it just takes a little bit of nous and know-how and understanding how we get the various true lengths that we needed. In this case, you can see we had the base as true lengths A, B, C, D, D back to A, and what we had to work out was the true lengths for all of these inside here. We used the triangulation method. As you can see, we had a series of triangles. Well, we actually only had 4 triangles, but at the top of it here, they almost look like triangles, but you can see this side of this portion of it here is actually curved. But we just took the true length straight from the top of it as well. It's just understanding what true lengths to use. So that's why you can see it might be a little bit messy up here, but what I would always do is make some form of a note of what true length is for what. So in case I'm ever getting confused, I can say, right, true length 1 to A, 4 to A, 1 to D, and so on. And that's how I would use it. Now, last little bit, I'll just explain here. The reason I put these lines in, they're important because they show us that as we were going along, we have all the right elements in, because we've got 4 big triangles, which we had 4 big triangles here, and we've got 1, 2, 3, we should have 12 of these little sections, and we have 12 of them over here. So you know you're done then, and you've it done right. The reason I haven't put it in these lines here, why I haven't hatched those in or dotted those in like we do with fold lines usually, is because this piece is actually a transition piece. There's no actual definitive edge where if you took a piece of paper and folded it over and it had a corner in it, there is no definitive edge. It just envelops around itself. Okay, I hope you found that helpful, guys. Some very important bits in that question there, and other questions that come up like that, if you use that method, it should help you. Okay.